All right, this lesson is on the difference between arithmetic and geometric sequences, which are both sequences that you've already seen, but we're going to talk more specifically about how they are different from each other. So an example of an arithmetic sequence would be something like 4, 7, 10, 13, so on and so forth. And the reason why this is considered arithmetic is because you are adding the same number each time. So here you start at 4 and then you add 3 to get to the next term in your sequence. You add 3 to get to the next term, you add 3. Similarly, if I had a sequence that was like 4, 1, -2, so on and so forth, then that would be arithmetic because you're subtracting the same number. So when you are adding or subtracting the same number in the sequence, that means that it is arithmetic. All right? So now a geometric sequence, an example of a geometric sequence would be something like 5, followed by 10, 20, 40, 80, so on and so forth. This is geometric because you're not adding the same number each time, you're multiplying by the same number. So here, what's common is the factor of 2. I'm multiplying by 2 to get to each sequence, or to get to each term in my sequence. Another example would be something like 8, 4, 2, 1, so on and so forth, because I am multiplying by the same number, which is a half, or you could say I'm just dividing by 2. So hopefully you understand the difference between arithmetic and geometric sequences. So like I promised you, it is going to get easier. This chart I think is going to be really helpful to you in order to figure out how to do arithmetic and geometric sequences. But you have to be able to identify what type of a sequence it is. So the recursive formula for any arithmetic sequence is going to be a sub n plus 1 equals a sub n plus d. Now here's the thing that you need to understand. You have to completely understand what d even means. So I need you guys to write yourselves a note that d is the common difference in your sequence. All right? So, for example, and this should make sense to you, this should say difference right here. This is a C. This should make sense to you because right here, to get to the next term in my sequence, I have to add 3. To get to the next one, I have to add 3 again. So that means that my d value in this example would be positive 3 because I'm adding 3. So again, this should make sense to you because I'm just taking it and I'm adding whatever the difference is. Hopefully you're okay with that. In this example, my d value would be negative 3 because I'm going down by 3. Okay? So each term is 3 less than the term before it. That's what this sequence would be saying if you were to plug it in. All right? So a geometric sequence is going to be a sub n plus 1 equals, this is n plus 1, just so that you know, okay, equals a sub n multiplied by r. Because remember, with geometric, you're not adding the same number, you're multiplying by the same number. And r is not going to be your common difference, it's actually going to be your common ratio. Okay? So, for example, in this example I gave you on the top of your page, the r value here is going to be 2 because you're multiplying by 2 to get to each sequence. And you can figure it out by taking each term and dividing it by the previous term. That will tell you what your ratio is, your common ratio. So 80 divided by 40 gives me 2. 20 divided by 10 gives me 2. Okay? So in this example, my r value would be 1/2 because 8 multiplied by 1/2 is 4, or I could just take this term in my sequence and divide it by the previous term. So 4 divided by 8, which would give me 1/2. All right? So that's how you find the recursive formula. Now, the explicit formula is going to be as follows. You need to have a sub n, and that's going to be equal to the first term in your sequence. So it's going to be a sub 1 plus the common difference multiplied by 1 less than the term. Okay? Now what we've done right here in this unit, we've done a sub 0 plus d times n. So instead of a sub 0 plus d times n, it's just going to be a sub 1 plus d times n minus 1. All right? And then the next example for the geometric sequence, it's going to be a sub n equals a sub 1, and remember a sub 1 is your first term in your sequence, multiplied by r to the n minus 1. And if you remember, when it was recursive, when it was geometric, you ended up getting an exponential graph, and that's why this is exponential. So let me write this out a little bit more clearly. A sub n equals a sub 1 multiplied by r to the n minus 1 power. Okay? Hopefully you're okay with that. Now, I have several examples that I want to go over with you guys in this video because I really want to make sure you get this. So please, I understand it's going to make the video a little bit longer, but you need to please make sure that you watch all of the examples so you completely get everything that we're doing here, okay? So the first sequence that we have goes from -2 to +2 to 6 to 10. So the first thing you have to decide is this arithmetic or is this geometric? The way you figure it out is whether or not you are increasing by a common difference or if you're increasing by a common ratio. So to go from -2 to 2, I'm adding 4, 2 to 6, you add 4, 6 to 10, you add 4, which means that I'm adding by a common difference, not multiplying by a common ratio, which makes this sequence arithmetic. All right, so we're going to write down right here that this is arithmetic. Now, what is the pattern? What's happening? Well, every time I want to figure out the next term in my sequence, I have to add 4 to it. So that means that my pattern is just going to be a +4 pattern. It's just going up by 4 each time, okay? So now I know in these boxes right here, recursive and explicit, they're small boxes. You're going to have to squeeze in your information here. I'm going to write it down here so you can see it a little bit more clearly, okay? But let me remind you that the formula for a recursive sequence is going to be as follows. You can see it right up here at the top of the paper. The formula for the recursive sequence is right here. So a sub n plus 1 equals a sub n plus d. So for my recursive formula, I'm going to say that a sub n plus 1 equals a sub n plus 4 because my common difference is 4. Okay, that's my d value. Now this should make sense to you because to figure out the next term in your sequence, you take the term you're on and you add 4. So to figure out what the second term of my sequence, I find out what the first term is, which is -2. I add 4 to it and I get 2. Okay, so this is my recursive formula, but I have to identify what a sub 1 is. So this is going to work for a sub 1 equals -2 and n is greater than or equal to 1. Okay, now let's do our explicit formula. In our explicit formula, if you guys look right here, our explicit formula is going to be a sub n equals a sub 1 plus d times n minus 1. All right, so I'm going to say a sub n equals, now I know what a sub 1 is. It's going to be this value right here. So my a sub 1 is -2 plus my d value, which is 4, times n minus 1. And then all I'm going to do is I'm going to distribute it. So I get a sub n equals -2 plus 4n minus 4, which means that my a sub n is going to equal 4n minus 6 for n is greater than or equal to 1. All right, now this is what I need you to fill in into your box. And this is what I need to fill into your box as well. This work right here, just find a little spot maybe like where you have pattern right here to fill in that work. Okay, so for the remaining ones, don't try to squeeze in all the work. Now let's talk about this for a minute. Remember, it all goes back to, if it's linear, it's going to go back to your equation of a line, y equals mx plus b. This is increasing at a rate of 4 per term. And if a sub 1 is -2, that means that a sub 0 would technically have been -6. So that's where this comes from. So either one of these will get you to the right formula. All right, in this example right here, your sequence is going 2, 4, 8, 16. So I need to figure out, is my sequence arithmetic or is it geometric? So am I adding the same number each time or am I multiplying by the same number each time? So to go from 2 to 4, I could either add 2 or multiply by 2. To go from 4 to 8, I could either add 4 or multiply by 2. If you notice, what's in common is that I'm multiplying by 2 each time. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, which means that I am multiplying by a common ratio, not adding by a common difference, which means that it has to be a geometric sequence. Okay? Now that I know it's geometric, I have to identify what the pattern is. And the pattern will tell me what my common ratio is. And my common ratio is 2, because 2 times 2 is 4. Now this is obvious because it's an easy example, but I need you to get in the habit of taking one term, so I'm going to take the term 4, and divide it by the previous term to figure out what your ratio is, because sometimes it's not as inherent or as obvious for you to figure out that the ratio is this number, okay? So next thing I need to do is find my recursive and my explicit formulas. Remember, do the workout somewhere on your paper. I know there isn't much room, but somewhere on your paper, and then put the boxed answer into your chart. Okay, so if I want to figure out what the recursive formula is going to be for this geometric sequence, I'm going to use the formula that I have right on the top of my page, which is a sub n plus 1 equals a sub n times r. So all I'm going to say is that a sub n plus 1 equals a sub n multiplied by 2, because I know that that's my first term in my sequence. So I'm just going to rewrite this in a slightly different order. So I'm going to say a sub n plus 1 equals 2 a sub n. And that should make sense to you because each term is twice as big as the term before it. Don't forget to define what a sub 1 is. So for a sub 1 equals 2, and n is greater than or equal to 1. All right? So that right there is going to be what my recursive formula is. I'm going to fill that in right into my chart. Okay? Now for the next one, I need to figure out what my explicit formula is. Now my explicit formula is going to be a sub n equals a sub 1, which is 2, multiplied by 2 to the n minus 1 power. Okay? For n is greater than or equal to 1. Now this should make sense to you that it is exponential because I'm multiplying by 2 repeatedly over and over and over again. So I multiply by, to go from 2 to 4, I multiply by 2 once. Since 4 is the second term and I multiplied by 2 once, it would be the second term minus 1, which is 1, so I multiply by 2 once. Hopefully that makes sense to you. Let me explain this to you one more time. So like another example would be 16. This 16 is my fourth term, so you don't have to write this down, but in this example, my 4 would be n because 16 is the fourth term, and I'm multiplying by 2 3 times, so 2 to 4 there's once, 4 to 8 is the second time, 8 to 16 is my third time. So I'm really multiplying by 2 3 times, which is n minus 1. So I'm multiplying 2 by itself one less time than the term number you're at. All right, so now that we've done one of each example, the next 4 examples should hopefully solidify your understanding of what it is that we are doing. So in the third sequence that we have, the sequence is going from 1 to 1/3 to 1/9 to 1/27. So you're not adding the same number each time. In fact, what's happening is you are dividing by 3 each time. But remember, when you divide by 3, it's the same thing as multiplying by 1/3. So because it's a common ratio, it means that your type of sequence for this problem has to be geometric. Okay, so I'm going to say that this is geometric, which means that I have to find my r, and my pattern is that it is being multiplied by 1/3 each time. Okay, so now let's find our recursive sequence. Now our recursive sequence is going to be a sub n plus 1 equals a sub n multiplied by 1/3. So I'm going to say that a sub n plus 1 equals 1/3 of a sub n, which should make sense to you again because each term is 1/3 smaller than the term before it. Okay, for a sub 1 equals 1 and n is greater than or equal to 1. All right, now let's figure out our explicit formula. So our explicit formula is going to be, our explicit formula is going to be a sub n equals a sub 1, which is 1. Make sure you're looking back at the formula on your paper, multiplied by the r, which is 1/3, raised to the n minus 1 power. Okay? So, and that's for n is greater than or equal to 1. So this is what's going to go into my explicit formula box, and this is what is going to go into my recursive formula box. All right? All right, the next sequence starts at 1/2, then it goes to 1, then it goes to 3/2, which is the same thing as 1 1/2, then it goes to 2, then it goes to 5/2, which remember is the same thing as 2 1/2. So see if you can figure out what the pattern is, and see if you can determine whether it's a geometric sequence or an arithmetic sequence. Write down your answer, press pause, and then come back to me to see how you did. All right, you should get that this is an arithmetic sequence because it has a common difference. This time I'm not multiplying by anything to get to the next number. What I'm doing is I am adding a half each time. So 1/2 plus 1 is 2/2, which is 1. 2/2 plus 1 is 3/2. Keep going. That's what your pattern is. So that means that D is 1/2. Okay, so let's find our recursive formula. Our recursive formula is going to say that a sub n plus 1 equals a sub n. Each time I'm adding on a half, so a sub n plus 1/2. And that's going to be true for a sub 1 equals 1 and, a sub 1 equals a half, and n is greater than or equal to 1. All right, so this can go right into your recursive formula box. Now let's talk about your explicit formula. Your explicit formula says that I have to take a sub n and set that equal to a sub 1, which is 1/2, plus the common difference, which is 1/2, multiplied by n minus 1. And I'm going to go ahead and go through and do my distributing. So a sub n is going to equal 1/2 plus 1/2 n minus 1/2. These two guys cancel each other out right here, so I end up getting a sub n equals 1/2 n. For n is greater than or equal to 1. Okay? And again, this should make sense to you because the first term in your sequence, your a sub 1, would be 1/2 times 1, which is a half. Your second term of your sequence is 1/2 times 2, so a half of 2 is 1. So each time you're taking half of the term number that you are in your sequence. So for example, if I want to figure out what the fifth term in my sequence is, I would do half of 5, which is 5/2. Okay? All right. All right, so for the next one, your type of sequence, you have to figure that out, so go ahead and think about that. Okay, you should get that it is an arithmetic sequence because it is decreasing by a common difference, not a common ratio. So the common difference is that it's decreasing by 5, which means that your D value here would be equal to -5. Okay, so now let's do a recursive sequence, or a recursive formula. So a sub n plus 1 is going to be equal to the previous term minus 5. So to get each term, I'm just subtracting 5 to get to the next one. So a sub n plus 1 equals a sub n minus 5. Now, that is true for a sub 1 equals 4 and n is greater than or equal to 1. So you can go ahead and fill this into your recursive formula box. This next one, you're going to need to do some work outside of the box, and then we'll fill in our answer. So for the next one, for the explicit formula, I have to figure out what the equation is going to be. So I'm going to figure out what a sub n is by doing a sub 1, which is 4, okay? And this time I'm not going to say plus 5, I'm going to say minus 5 because it's decreasing by a common ratio of 5, multiplied by n minus 1. And then I can go through and distribute it. So I end up getting 4 minus 5n. Be really careful, this is a plus 5. So then you get a sub n equals 9 minus 5n, which again should make sense to you because your a sub 0 would technically be 9, and you're subtracting 5 for every term that you are doing in this sequence. So we're going to say for n is greater than or equal to 1, and then we are done with this problem. All right, last one. Our sequence is going from 10 to 1 to 1/10th to 100th to 1,000th. So every time I'm figuring out what the new term in my sequence is, I am dividing by 10, okay? So that means that I am not adding or subtracting a common difference. I'm multiplying by a common ratio. So I'm going to say that this is definitely going to be a geometric sequence, okay? Now, what is the common ratio? If I'm dividing by 10, that's the same thing as multiplying by 1/10th. But remember I told you, take one term in your sequence, divide it by the previous term, and that's how you figure out what your R value is. So that means that R is 1/10th. I could do it again for example, if I were to use the third term in my sequence, I could say that it's 0.1 divided by 1, which is 0.1, which is, if you were to read this properly, this is 1/10th, so that means that your ratio is 1/10th. Okay, hopefully that makes sense to you. All right, so the next thing that I need to do is I need to determine what is my recursive formula. So my recursive formula is going to say that a sub n plus 1 is equal to 1/10th of the term before it, which is a sub n. For let me just write this out one more time. 1/10th of a sub n for a sub 1 equals 10, and n is greater than or equal to 1. So you can go ahead and fill that into your recursive formula box. And then the explicit formula is going to be a sub n equals a sub 1. Now in this example, your a sub 1 is 10, multiplied by your common ratio, which is 1/10th, all of that raised to the n minus 1 power, okay, for n is greater than or equal to 1. All right, we will get some more practice with this so that you are pros at finding recursive and explicit formulas of arithmetic and geometric sequences. See you next class.